I'm Dr. C, and this video considers what is physics. Although actually, I'm kind of lying to you. I intend to expand it a little bit, to be truthful. I'm actually going to consider what is physics, but I'm also going to consider why do we bother with the subject? Why is it important? And finally, what can physics do for us? Okay, let's start with what is physics. This is Richard Feynman. Richard Feynman was a Nobel Prize winner in physics, which means he was red hot at physics. He was a theoretical physicist, which means he was red hot at mathematics. And he was born in 1918 and died in 1988 of cancer. So, if you think about those years, that means he was born through the video age. In other words, when we had video, when we had TV. Which means that if you look him up on YouTube, you'll do yourself a favour because he was amazing. And you can look at him kind of for real teaching. He was absolutely captivating as a person. And it is fair to say that there is no professional physicist in the world that doesn't know his name. And to an awful lot of us, he was a hero. Oh, and for sure, he was a genius. I'm not going to say that I really know what that word means. I guess we could define it in different ways, and I'm not sure whether any of them really make any sense. But whatever a genius is, he was one. He was in the same league as Isaac Newton and Albert Einstein. I find it slightly amazing that not so many people know about him as compared to those two, because the guy was amazing. The reason that I bring up Richard Feynman is because Richard Feynman was asked this question, what is physics? And he had a particular way of explaining it that I think is really quite interesting. Feynman answered this question by asking you to consider that you walk into a room and you see two people in the middle of the room sitting opposite sides of a table and they're playing a game. It's the game of chess. But you have to pretend that you've never seen the game of chess before. And if you look at the game of chess, it's really quite weird. And the challenge is to look at the game of chess being played and to take a pen and paper and try and basically write down the rules for chess. That's what Feynman asked you to consider. And the argument is this. Can you write down the rules of chess purely by watching the game of chess being played over and over and over again? And I think the answer is yes, you can. Maybe. Could you ever know for sure? Well, it depends. It depends how much you've watched. Certainly, if you watch the game of chess being played for 2 or 3 minutes, probably not. But if you watch it over and over and over again, then maybe yes. You watch game after game after game. You cannot ask the players why they play the moves that they make. The two people that are playing the game, they move their pieces, they never speak, and you can't ask them any questions. So, imagine you've watched 12 games. 12 games is an awful lot of moves. After 12 games, you feel fairly confident in saying that whatever this game is, it takes place on an 8 by 8 squared board. Alternate squares are alternate colours. And the initial setup of the pieces is in a particular way. And you would maybe have to, I don't know, draw some images for what the pieces are because they look different to each other and place them so you can show the opening position. How do you know this? Well, you know this because the first 12 games, every time they restart a game and set it up, they always start in that particular way. And for example, let's just call the pieces piece 1, 2, 3, or maybe piece A, B, C, just to distinguish them. Or maybe you want to give them more interesting names, like a bishop and a knight. It doesn't really matter, it's just a way of distinguishing the pieces, that's all. The bishop, for example. You might say that the rules of the bishop are bishops can only move diagonally, which means they always stay on the same coloured squares. They can move as many squares as they like, but they cannot jump over a piece. They cannot land on a square that has a piece of the same colour. And if they land on a square with a piece of the opposite colour, then that piece is removed from the board and it no longer takes part in the game. And that's basically it for the bishop. Now, again, how do you know that those are the rules for a bishop? And the answer is, well, you don't. But in the 12 games that you've watched, bishops have moved quite a lot. And that's the only way that they've been moving. The only way that a player has moved a bishop is in agreement with the bunch of rules you've just created for it. So you think that those are the rules for the bishop until you see something different. Okay, on the 13th game, imagine something happens that just by fluke didn't happen in the first 12 games. In the first 12 games, it just so happened that a pawn never reached the end of the board. But in the 13th game, that happens. Now the pawn is a crazy complicated piece anyway. And when the pawn reaches the end of the board, suddenly it turns into a queen. And this is a crazy moment because it's new, you've never seen this before. How can a piece just turn into another piece? But it does. So you look at your rules for the pawn, and actually you don't have to change any of them. What you do is you basically say, if a pawn ever reaches the end of the board, it turns into a queen. And then maybe when you've watched 1,000 games or 100,000 games or 1,000,000 games and you look back at your rules for a pawn, that rule may now be different. If you read it now, you'll probably say something like, if a pawn ever reaches the end of the board, it seems to turn into a random piece. Because of course it's up to the person what it becomes. But to try to explain that in your rules, you've had to introduce the concept of randomness. Well, Feynman said that's what physics is. Physics is like watching a game and trying to work out the rules of the game. But the game is not chess. In physics, the game is everything around us. It's from things that are smaller than an atom to things that potentially are larger than a universe. It's everything. Every piece of information that we have around us is a clue to give us an idea of the rules of the universe. What are the rules that make our universe work the way that it does? That's what physics is. For example, if you look around the room that you're sitting in right now, you'll probably see lots of things that are red. Now, have a close look at a couple of things that are red, and what you'll notice is that they're not the same shade of red. Now, that's a clue. The universe is giving us information there. What is it that makes the different shades of red look like different shades of red? What is it about the pigment? What is it about the material that makes the reds look different? These things are called the rules of the universe or the laws of the universe, or they're the rules of physics or the laws of physics. And there are two important things to say about these laws. One, they cannot be broken. If someone, for example, were to do an experiment that were to show us that one of the laws of physics actually is not correct and we break it, then what that actually means is that that wasn't a law of physics. It wasn't a rule of the universe. We were mistaken. In light of new evidence, we now know that that rule isn't one of the rules, and we have to recreate a rule that takes into account that new information. So we don't break them, we modify them. And the second thing, you can't ask why the rules are the way that they are. It would be like asking in chess, why does a bishop move diagonally? And the answer is, well, because it does. It's a rule of the game. Well, I suppose actually, if I think about it, I can probably think of a slightly better answer than that. If someone said to me, why does a bishop move diagonally in chess? I could answer, well, because it makes for an interesting game of chess if one of the pieces moves diagonally. So I suppose I could say, if I wanted to, why are the rules of the universe the way they are? Because they make for an interesting universe, with us in it now, talking about it. This is one of the rules of physics, or the laws of the universe. It's called conservation of energy. You cannot create or destroy energy, only convert it from one form to another. I actually don't like that way personally of saying it. I think there's a nicer way of saying the law of conservation of energy, but we'll stick with this way at the moment because it's the one that most people know about. Now, the question, can it be broken? Why is it that we can't create or destroy energy? Answer, we don't know. Can it be broken? Well, we would try to find out by doing experiments, by making so-called empirical observations or getting empirical data, which means based on observations. So in this way, the laws of physics can be flexible, but only with respect to the idea that there will be more evidence in the future, and as we learn more, as we gather more evidence, we will adjust what we think the rules of the game are, just like we did with the pawn. Okay, so let's put physics now into the full scope of science. Most people like to think of science as basically being biology, chemistry, and physics, although there seems nowadays to be a million different types of areas of scientific study that fall outside of those three. But let's just stick with those three at the moment to keep things relatively straightforward. Most people think, as we try to compartmentalize our thoughts, that the scope of science is basically like this. Biology, chemistry, physics, and of course there'll be an overlap. So for example, that overlap there might be considered biochemistry. Now, if you like this idea of trying to compartmentalize science, then I have to tell you, it's wrong. That is not correct. It is not a good reflection of what science is. If that's the way you like to think about things, then this is a better way of describing the scope of science. Biology, chemistry, physics. Now, people will look at this and say, Dr. C, you're just being biased here. You're trying to somehow suggest that physics is the best of the sciences because it's kind of like bigger and it kind of covers the others and all that kind of stuff. And actually, it's kind of right and not right. I'm not trying to be biased here. The questions that physics ask are the kind of questions that create this scope for science. Physics is interested in working out why the universe works the way it does. In biology, for example, there's photosynthesis. Now, a physicist is interested in photosynthesis, but we're interested in a different question than the biologists. In chemistry, you would say take hydrochloric acid, sodium hydroxide, mix them together, and you'll get common table salt, NaCl, and water. Now, chemists are interested in that because they might want to make salt, for example, but a physicist is interested in that because it tells us something about the universe. Why is it that those two molecules, HCl and NaOH, they're kind of happy on their own, just sitting there, but when you put them together, they always reform themselves into NaCl plus water? We want to know why, because that's telling us something about the universe. Because it's reproducible and it always happens, it must mean that there's a rule that determines that. And we want to know what that rule is. This is the way that physics functions. This is why everything that a biologist and everything that a chemist is interested in, we're interested in as well. We just ask different questions. Okay, so the second part that I wanted to consider was why bother with physics? Why would we be interested in knowing the rules? What is it about the human condition that wants us to ask these kind of questions? Why is it that it's important for us to ask the question, why are things the way they are? And the answer is, I actually don't know. I don't know what it is about the human condition that makes us do that. And the really interesting thing about physics is it's like a puzzle that just never ends. No matter how deep you go, there's a deeper level. No matter what kind of answer you come up with as to why something happens, it will just lead to other questions. Why does a wire get hot when an electrical current flows through it? Because electrons go through it. And the electrons collide with the atoms. And the atoms then end up making the wire hot. Okay, well, why do electrons colliding with atoms, why does that make the wire hot? Okay, now I have to start looking at what I mean by hot. So this is the way that we progress, by asking question after question after question. And what we're doing is we're pushing the boundaries of our knowledge more and more. It is this weird idea that as you go deeper and deeper and deeper into physics, you just get more and more and more problems to solve. There is this endless complexity as we go more and more into the structure of why things work the way that they do. And it's a puzzle that will last for a lifetime or more. Isaac Newton, Albert Einstein, Richard Feynman, they all died thinking about physics, thinking about problems that they could not solve. No matter how good you are, physics is always going to have questions that you cannot answer. And that's actually not a problem. That's why it's such a great subject. Because if you like puzzles, there will be no end to the puzzles that you will be asked to try and solve. What you have to do is never give in. You have to dig deep, work hard, and sometimes make inspiring leaps. The process of trying to do this is commonly referred to as the scientific method. The scientific method is presently felt to be our best way of trying to move forward with our knowledge of the universe. And if you focus yourself on the scientific method, it will give you a level of skepticism that will serve you well in life. It will allow you to ask the right questions, like not to make fallacious statements. And importantly, it allows you to focus on the key issues that prevent our progress. It is very, very important. It's part of a good life's journey. And remember, the enjoyment of puzzles is not in the answer. It's in the process. The mental acrobatics that are sometimes needed are just absolutely amazing. And if it grabs you, it'll grab you for the rest of your life. It will dominate the way that you think because it is crazy good. Okay. And the final part of this video is, what can physics do for us? To be good at physics, you not only have to be good at problem solving, but you also have to be good at mathematics. You could argue that physics is the study of problem solving. And we basically use mathematics to do that, to solve the problems. So if you do a physics degree, then you basically give yourself two very high level skills. You get a high level of practical problem solving, second only to someone with an engineering degree, and you get a massively high level of mathematical knowledge, second only to someone with a maths degree. And physics bridges those two disciplines, and people will pay you for having those skills. And we're not just talking about science. It could be customer relations in a bank. It could be stock control in a shop. It doesn't have to be a scientific question. And just a final point here. An awful lot of my students in the past that are good at maths and good at physics and enjoy physics and kind of enjoy mathematics, they end up applying for an engineering degree rather than a physics degree. And I ask them why. Their answer is because, I want to get a job when I finish, and I've probably got more chance of getting a job if I'm an engineer rather than a physicist. Well, I can tell you that any company that's interested in an engineer will also be interested in a physicist. It is not the same the other way around, though. There are some companies, in particular software companies, that end up using an awful lot of your mathematical ability. And they're looking essentially for people with a maths and a physics degree, and they will not be interested in general in someone with an engineering degree. So actually, a physics degree gives you more options for employment than an engineering degree. So we need to hit that one on the head straight away. This subject is amazing. It is the business. Now, I do intend to make more videos on the topic of physics and the use of the scientific method. So if you like this video and you want to make sure that you don't miss any of them, then consider liking it, sharing it, and subscribing, because if you like it, of course, that's just kind of nice, and we all want to be nice, don't we? If you share it, it means that you spread the love. And if you subscribe, it means that you'll get told if I then post up new videos. and I hope you've enjoyed this, and remember, be good and be safe.